Hi, this is Mrs. Rodriguez with Introductions to Inequalities lesson. All right, so inequalities. We've been working on equations where you have an equal sign and you're solving for the variable, right? You're solving for like x or y. Inequalities are a little different. Inequalities, you're not just solving for one number. Inequalities are used when there's more than one number, when there's a range of numbers. So for instance, how old do you have to be to drive a car? 16. But can only 16-year-olds drive a car? No. You could be 17, you could be 20, you could be 40, you could be 60. There's a range of ages you can be to drive a car. So an inequality can show that by saying that x is not just 16, right, to drive a car, but x is all the numbers that are 16 and greater, okay? Or if you wanted to represent how tall you need to be get on a roller coaster ride, maybe the height requirement is 4 feet to get on a roller coaster. You could write an inequality to represent that by saying that, x is all the heights that are 4 feet and over. So that's what inequalities are for, to show a range of numbers when there's more than one numbered answer. So let's go ahead and get started with today's lesson. An equation uses, let's change this color, uses an equal sign to show that both sides are equivalent. Now remember, equivalent means equal or the same. An inequality shows that both sides are not equal. So with inequalities, one side's going to be bigger or equal to the other side, or not equal, okay? So greater than is represented like this. Greater than or equal to, it's the same symbol, but we draw a line under it for the equal sign. Think of it as greater than and equal combined together. Then less than looks like this. Less than or equal to, and not equal. Use an inequality symbol to create a true statement. So 4 and 9. Well, 9 is bigger than 4, so go like this. Now, if you're having trouble understanding which way the symbol goes, a neat trick you can do is you can think of it like a Pac-Man, okay? And Pac-Man always eats the bigger number because he's hungry. So I like to draw the Pac-Man body, and then that tells me which side Pac-Man's facing, and whatever side Pac-Man's facing is the bigger number. So 0.5 and 0.45, I know 0.5 is bigger, so Pac-Man's going to be eating 0.5. Does that make sense? And if he's going to be eating it, it's going to face that way. For -3 and -2, remember you're looking at a number line. Here's my 0. -1, -2, -3. 1, 2, 3. -3, you would think, is a bigger number because it's got a 3 in it. But -2 actually is closer to 0, 1, 2, 3, the positive numbers, right? So it's actually bigger than -3. Okay, because it's more towards the larger numbers. All right. -6.1 and -6.10. These are actually the same. Hold on, let me get my pen. These two are equal. You don't have to draw the 0 next to that 0.1, but you can if you want to. So they're actually the same number. And then 12.4 and 12.04. 12.4 is going to be bigger. And keep in mind, this would be 12.40, and then the other one is 12.04, and you can see that 4 makes it bigger. That's 40 cents as opposed to 4 cents. All right. Write a verbal description to represent the inequality statements below. So now they want us to take our inequality and write them using words. So for the first one, we see that Pac-Man is actually eating the X. So that means X is bigger than 6. And it has that equal sign underneath. So that means that X is bigger than or equal to 6. So 6 is less than or equal to X, or you could say, and X is greater than or equal to 6, okay? In the second one, Y and 0.5. Well, we'll notice this time Pac-Man's still eating in the same direction. So 0.5 is bigger than Y. There's no equal sign underneath it, so that means that Y is just all the numbers smaller than 0.5. So we could write that as Y is less than 1/2, and 1/2 is greater than Y. Either way is good. Use the variable as the starting point when reading inequalities. So, determine whether each value makes a true statement. So now they're going to give us what the variable equals, and we're going to plug it in and we're going to see, is this true? So in this case we have k plus 8 is greater than or equal to 19. So if k is 11, that means 11 plus 8 should be greater than or bigger than or equal to 19. So 11 plus 8 is 19. Is it bigger than? No, but it is equal to, so it still works, and this is true. For number 2, now we have f is 3, and I'm going to plug that in. So 12 is supposed to be greater than 3. Well, yes, that's definitely true. And for 3, we have d equals 3. So 3 is greater than 3. Is that true? No, they're equal because it's the same number. So this one would be false. Go ahead, I want you to do 4 through 9. Pause the video, do 4 through 9, see what you get, and then when you're ready to check your answers, go ahead and resume the video. Pause the video now. Welcome back. So for 4, when you plug in that 13, you get 13 minus 12 is greater than 30. 13 minus 12 is 1. 1 is not greater than 30, so this is false. For 5, we have 22, so 16 is greater than 22 minus 8. 22 minus 8 is 14. 14 is not bigger than 16, so this is false. Okay, now we have x equals 5, so that would be 6 times 5 plus 5 is less than 18. 6 times 5 is 30. 30 plus 5 is 35. 35 is not less than 18, so this is false. For 7, we have j equals 5, so that would be 2 times 5 is less than or equal to 8. 2 times 5 is 10. 10 is not less or equal than 8. So once again, false. We have a lot of falses. Now we have r equals 6. So we have 5 times 6 minus 3 is greater than or equal to 25. So that's going to give us 30 minus 3, which is 27, is greater than or equal to 25. And that is true. It is greater than. And last but not least, we have m equals 8. So 6 times 8 minus 12 is less than 40. That gives us 48 minus 12. And 48 minus 12 is 36. Oops, this is supposed to be an 8. 36, and 36 is less than 40, so this is also true. Okay, pat yourself on the back if you got those correct. All right, moving on. Inequalities can also be graphed on the number line. So this is how it works. When you graph, you're going to be given a number line, like so, okay? And when we have something like x is less than or equal to 5, well, they give us the number 5, and we're going to draw a circle on that 5. Now, there's two different types of circles. There's the filled in, which is included, and the not filled in, which is not included. Now, what do we mean by included? Included means not only is it less than or equal to, or I'm sorry, not only is it less than or greater than, but it's also equal to. So remember, that's the ones that have that bar underneath showing that it's also equal. If that's the case, the bubble's filled in. So in this case, we have that right here, so our bubble's going to be filled in. Okay? So that means not included, the open bubble, is when you have the greater than or less than, but not included. Now our second step is to draw an arrow, and that arrow is going to represent all the numbers that x equals. So in this case, x is all the numbers smaller than or equal to 5. So that bubble filled in takes care of the equal part, and then all the numbers smaller than 5, we represent that by drawing an arrow in the direction of all the numbers smaller than 5. Okay, so we'd be going towards 0 and negatives, right? Because that's smaller than 5. So let's take a look at a couple of more examples. Practice graphing the following inequalities. So k is greater than 11. There's no equal to, so I know my bubble stays open. So our number is 11, so where there's an 11, I'm going to draw an open bubble, right, an open circle. And then k is all the numbers larger than 11. So my arrow is going to go towards all the numbers larger than 11. For number 11, we have 12 is greater than or equal to f. So now we're going to have the bubble on 12. We have that equal to added on there, so my bubble's going to be filled in. And then I'm going to fill in, or I'm going to draw my arrow on all the numbers that are equal to f. And in this case, f is smaller than 12, so my arrow is going to go in the direction of the numbers smaller than 12. For number 12, we have d is smaller than 6. So I'm going to have my bubble. There's no equal to, so the bubble stays open. And now d is smaller than 6, so I'm going to draw my arrow towards the direction of the number smaller than 6. Go ahead and, let's see, pause the video. Uh-oh, what happened? Go ahead and, let me see, technical difficulties. There we go. Pause the video, do 13, 14, and 15 on your own, and then when you're ready to check your answers, go ahead and resume the video. Pause the video now. Hi, welcome back. Okay, so for C, we have 13. C is less than 25. The bubble goes on 25. It stays open because there's no equal to, and C is less than 25, so it goes to the left. 14, 0 is less than or equal to B, so my bubble is on 0. I have the equal sign on there, so it's going to be filled in. And B is bigger than 0, so my arrow goes that way. In this case, we have 4.5, so my bubble's going to go between the 4 and the 5. There's the equal sign on there. It's less than or x is greater than or equal to, so my bubble's going to be filled in. And because x is greater than or equal to, it's going to go towards, the arrow is going to go towards all the numbers bigger than 4.5. Based on the verbal expression below, write and graph an inequality. So for 16, the McDonald family spends no more than $150 for groceries each week. So we have x and we have 150. No more than 150 means they can't spend anything bigger than 150, right? So x is going to be less than 150. 150 is going to be the biggest. Could it be less than 150? Absolutely. So X is definitely smaller than 150. Could it equal 150? Yes, it could also equal 150. They just don't spend more than 150. So they can spend $150 or less on groceries a week. So X is going to be less than or equal to 150. So now we have to graph it. And when you're graphing, keep it easy. You know, I would put maybe 150 here, let's say, and then I'll make this 160. I'll go by increments of 10. So you don't have to draw a number line all the way to 150. That would take a long time and be a pain. So go ahead and just choose some numbers greater than and less than and keep it like that on the number line. X is less than or equal to, so my bubble's filled in. And because X is smaller than 150, the arrow is going to point to all the numbers smaller than 150. So for 17, Jared earns at least $10 per hour when he's mowing lawns. So we have our X and we have $10. He earns at least $10, which means he can earn $10 or more than that, okay? But he can't earn $6 or $7. He can't earn anything less than 10 because at least means that amount or bigger. So that means X is definitely greater than 10, but can also be 10. So now that when we graph it, I'm just going to do it in increments of 5 maybe. So 5, 10, 15, 20, 25. Once again, it doesn't really matter. Just choose some numbers bigger than and less than on your number line. And then X is greater than or equal to 10, so our bubble's going to be filled in. X is all the numbers bigger than 10, so the arrow is going to go towards the right. All right, so moving on. We have model problems. So we have 4 examples to graph. Go ahead and pause the video, and when you're ready to check your answer, go ahead and resume the video and see if you got it correct. Pause the video now. Okay, welcome back. So for the first one, we have the number 0, and it has the equal sign on it, so I know my bubble's going to be filled in. X is all the numbers smaller than 0, so my arrow is going to go to the left. For the second one, we have -1. There's no and equal sign, so it's just an open bubble. And X is all the numbers bigger than 1, right? Remember, Pac-Man's eating X, so the arrow is going to go to the right. For the third one, we have -5, and there is the or equal to on there, so it's going to be, a filled in bubble on -5, and X is all the numbers bigger than or equal to, so the arrow is going to go towards the positives, the bigger numbers, which is to the right. And then last but not least, X is smaller than 5. There's no equal sign on there, so the bubble stays open, and the arrow is going to go towards all the numbers smaller than 5. Graphing. So here's more examples of graphing to help you practice the skill. I'm just going to really quickly say that this is just practice, practice, practice. The more you practice, the better you'll get. On this one now, you are going from the graph and you're actually writing the inequality, okay? So before we had the inequality and you had to graph it, but now we're going backwards. So I definitely want to show you how to do these. So for the first example, I know that bubble is on the 0. So for each of these, you can just quickly write your X's, right? And then write the numbers that the bubbles are on. So in the first one, we have 0. The second one, we have -1. Third one, we have -5. And in the fourth one, we have a regular 5. And then I see which direction. Is the X all the numbers bigger than or smaller than? So for the first one, X is the number smaller than 1, or I'm sorry, 0. So, So the Pac-Man's not going to eat the X, the Pac-Man's going to eat the 0. And then the bubble's filled in, so I know it has an equal sign attached. For the second one, X is all the numbers bigger than -1. So that means X is bigger than -1. The bubble's filled in, so there's no n equals sign on there. And then for the next one, X is all the numbers greater than -5. So Pac-Man's eating X. And the bubble's filled in, so you're going to add that equal sign on there. And last but not least, you have X is all the numbers smaller than 5. The bubble's open, so there's no equal sign to add on. Okay? So for this next section, go ahead and pause the video, try to do it on your own, and then when you're ready to check your answers, resume the video. Pause the video now. Okay, welcome back. So once again, I'm just going to draw my X's. Then I'm going to write the numbers that the bubble is on. And then I'm going to go through and I'm going to see, is X bigger than or smaller than? And the arrows tell you what numbers X is, right? So in the first one, X is the number smaller than 7. So that means X is less than 7. The bubble's open, stays like that. For 2, X is greater than -2 and it's filled in. For 3, X is greater than -8 but not equal to because the bubble's open. For 4, X is smaller than -1, but the bubble's open, so not equal to. For 5, X is smaller than -7, but also can be equal to because the bubble's filled in. For 6, X is smaller than. For 7, X is, no it's not. X is greater than 1. And for 7, X is also greater than 1. They're both actually the same problem, so that was a typo. And then for 8, X is smaller than. For 9, X is less than or equal to. And for 10, X is greater than and equal to. Pat yourself on the back if you got those correct. Moving on. All right, so graphing and writing inequalities. So this is just a quick little summary of what we did today. So X is greater than or equal to 2. Oops, hold on one second. The bell. K is greater than or equal to 2. So you put your bubble on 2. It's also equal to, so you fill it in. And because K is all the numbers bigger than 2, the arrow points in all the numbers towards all the numbers bigger than 2. For number 2, we have S is less than 4, so I'm going to put the bubble on 4. There's no equal sign, so it stays open. And S is all the numbers smaller than 4, right? Because the Pac-Man's eating the 4. Remember, you can always draw the Pac-Man to help. So the arrow is going to go in the direction of all the numbers smaller than 4. And then we also learned how to go from the graph to writing the inequality. So we just write X, and then we have 8. Okay, the arrow's pointing to all the numbers smaller than 8, so that means X is all the numbers smaller than 8. And the bubble's filled in, so it's also equal to. So X is less than or equal to 8. All right, so this page here is your homework. So go ahead and get started on that. And remember, if you have any more questions, if you're still confused on something, or if you just need more help, you can always ask me during class or make an appointment to see me during office hours. I hope you have a great day. Bye.